The molar mass of a substance is the mass of a substance if we have 1 mole of it, which is Avogadro's number 6.022 times 10 to the 23rd. So if we have a mole of any of these elements, the amazing thing is it takes the atomic mass and converts it into practical units of grams. That's what the mole does for us. It connects our world to the atomic world. So the molar mass information is on your periodic table. Part A, phosphoric acid is made up of 3 atoms of hydrogen. And if we have a mole of that, the molar mass of hydrogen is 1.01. That's going to give us 3.03 grams per mole in 1 mole of phosphoric acid. Now phosphorus has a molar mass of 31.0, and there's only 1 of them. And oxygen has a molar mass of 16, and there's 4 of them. So that's going to be 64. All right, we don't know the precision to the 100th, so following significant figure rules, the molar mass of phosphoric acid is 98 grams per mole. So there's your answer to part A. All right, part B is a binary molecular compound, so we'll need to use the prefixes to determine the formula. Di means 2, so the formula is N2. Tri means 3, so it's O3. N2O3. Let's do that down here. So there's 2 nitrogens in N2O3, and nitrogen has a molar mass of 14.0. That's right next to oxygen. So that's going to give us 28.0 grams per mole. And oxygen, there's 3 of them. 16.0 is oxygen's molar mass, and that's going to be 48. Let's add them up. And that's going to give us 76 grams per mole is a molar mass for dinitrogen trioxide. Moving on, part C. Calcium carbonate is an ionic compound, so we'll need to use the charges to figure out the formula unit. Calcium forms 2 positive cations, and carbonate is a CO3 2 negative anion. So these 2's are going to cancel out. So the formula unit for calcium carbonate is CaCO3. All right, calcium has a molar mass of 40.1. And carbon has a molar mass of 12.0. And oxygen has a molar mass of 16.0, and there's 3 of them, so that's going to be 48.0. All right, let's add them up. So we get 100.1 grams per mole is a molar mass for calcium carbonate. Ammonium sulfate, it's another ionic compound, so we'll need the charges. On the cation is 1 positive, and sulfate is SO4 with a 2 negative charge. You crisscross them, and you'll get 2 ammoniums. So we'll need a parentheses around that, and then SO4. Oh boy. All right, we're going to need to distribute the number outside the parentheses to each element inside the parentheses. So for the nitrogen component, there's 2 of them, and nitrogen has a molar mass of 14.0. That's going to give us 28.0. Next, hydrogen, there's 8 of them. Molar mass is 1.01. It's going to give us 8.08. And sulfur, 30. There's only 1 of them. 32.0. It's up here. And oxygen, there's 4 of them. 16 is the molar mass. Going to give us 64.0. Alright, that 8 is in the hundredths place. The other values don't have that precision, so we can't use that when we're adding. So that's just a 0, 8, 8, 16, 10, 22. 132 grams per mole is the molar mass for ammonium sulfate. All right, C4H9O2. All right, so for the carbon component, there's 4 of them. Carbon has a molar mass of 12.0. That's going to be 48. Hydrogen, there's 9 of them. 1.01 is the molar mass for hydrogen. That's going to give us 9.09. And oxygen, 16.0. There's 2 of them. 32 is the oxygen component. .0 grams per mole is the molar mass for C4H9O2. Right, and then finally, bromine is a diatomic element, so the formula is Br2. There's 2 bromines, 79.9. So it's just 80 times 2 minus 0.2. So that's 159.8 grams per mole.